Our acclaimed keynote speaker of the day comes with 20 plus years of IT experience in various technology roles such as developer, operations engineer, and architect in the retail, healthcare, and finance industry. In his tenure at Capital One, he had served as a senior director of Capital One's enterprise architecture group and had led the company's DevSecOps initiatives. Currently armed with the role of Vice President, Architecture at Fidelity Investments, our DevOps evangelist believes his core strengths are in problem solving, teamwork, technology transformation, enterprise solution architectures, and software delivery team leadership. And that, ladies and gentlemen, is the essence of a world-class DevOps evangelist. Today, he's going to give us an insight on his observations from his vast experience of implementing DevOps and his engagement with various DevOps research and initiatives. Ladies and gentlemen, without much further ado, please help me in welcoming Dr. Tapabrata Pal, aka Topo, as he's fondly called.
Hi, welcome to my talk at DevOps India Summit 2021. By this time, we should all be very used to these virtual conferences and recorded talks, but believe me, I'm not. I miss in-person conferences, interacting face-to-face, sharing thoughts over lunch, after conference drinks, and dinner, and many more of these interactions. Hopefully things will become normal soon, and until then, these recorded sessions will have to do. My name is Tapabrata Pal. I go by Topo. At Topo Pal is my Twitter handle, and you can also find me on LinkedIn. I just want to tell you about myself a little bit before I start on my actual presentation. I'm currently a vice president at Fidelity Investments Enterprise Architecture team. I focus on DevOps domain for the entire company. Until about 5 months ago, I was with Capital One, where I spent my last 10 years of my career doing some interesting stuff around DevOps, CI/CD, cloud migration, etc. Essentially, I'm a developer, open source contributor, DevOps enthusiast, and a lifelong learner. I've been in this domain for quite some time now. I frequently interact with a lot of people on an ongoing basis and learn from them. I regularly attend Gene Kim's DevOps Enterprise Forum and participate in writing some research or white papers that address a lot of current day's DevOps challenges. So in today's talk, I thought I'll try to share some of my observations that I made over the years. I see these to be the top level concerns in large enterprises. But along with my observation, I'll also share some of my own opinions too. These are not specific to any company or organization or team, but at the same time, this could be true for any enterprise or organization. With that, let's start with the thing that I'm not going to talk about today, culture. Well, I just did in a way. Well, I just did it. Every DevOps discussion leads to a discussion of how to change the culture. Actually, I take it back. It leads to a discussion of how a culture cannot be changed. And hence, all these DevOps things won't work. Well, this is not useful. Not every organizational problem is a culture problem. Not every roadblock is a culture issue. We tend to mean that this is not going to change as soon as we say this is a culture issue. I have seen that a lot of times. This becomes an excuse for not working hard. Sometimes it becomes an excuse for keeping status quo. Sometimes we mean to say it's hard, let's not do it. Or even it's above my pay grade. I'm not going to get into a debate about what comes first, the technology, the tools, or the culture. We have enough evidence throughout the history of technology driving culture change and vice versa. So that debate is not useful. I think based on what I have seen and heard so far over the years, a lot of teams, organizations, enterprise have changed people's behavior and overcome obstacles and blockers to reap the benefit of DevOps. In many cases, it has been as simple as a small process change via tools that forced, in a good way, to change people's behavior and actually acted as catalyst for much bigger change. Usually, in an organization, the small changes are at the ground level, and that become the catalyst for the bigger changes that are mostly driven from the top. Let me use a real life example while I'm at it. I know of an organization, and the name of the organization is irrelevant here. They were 100% waterfall about 8 years ago. Every step of the development process was manual, based on no trust culture. Not that people were bad and they didn't trust each other. It was just the contrary. Amazing people, very skilled people, technically solid people, but the processes were ticket based, and the process was designed based on this no trust culture. It basically said, don't trust the other person. Get it in writing, get it in ticket, let every trail of the things be there in the system. Even developers could not build their own code. Forget about deployment. They could not even build their own code. Developers had to open service tickets for some third party to build their software. The third party did not even know what they were building. They just manually ran the build and packaging commands that are supplied by the developers. If the build failed, the tickets were closed and the error messages pasted in the response, and developers got that response back. They opened the ticket and saw it. And then if they need to fix something, they fixed it and opened another ticket. I mean, this is ridiculous. Developers sometimes, pause for a moment and take time. And by that time, the time is lost. Now, if you think about it, think about this culture, right? It's very, it's very counterproductive, right? So some folks in the, small team try to install a CI tool and automated some build process. Not a solid CI, it's just the build process, just automating the build and packaging. Then another team came to know about it and they did it too. And then another team, and then another team. And then the mid-level management came to know about it. And then the top-level management started seeing the cost benefit immediately. They did not need to pay the third party anymore, millions of dollars saving. So this was one of the catalysts for the organization to start a transformation journey. It did not start with a big bang culture change, or it didn't start from top down, but it actually ended up changing everything that the company is doing these days. A small team and a small set of tools acted as a catalyst. So that was my story to support my claim. So what I'm trying to say is that I kind of covered the culture aspect. I'm not talking about culture change. All I'm saying is that don't use culture change as an excuse of not doing DevOps. So that was my observation 0. It doesn't count. Let me now go over to the actual topic. My first observation about DevOps. It's about tools. I think this is the most loved and at the same time most hated side of DevOps. There's a lot of viewpoints on whether to centralize or the tools are not to centralize. And I'm going to share what I have seen so far. Everyone knows tools are essential, and the words DevOps, continuous integration, continuous deployment, all these words immediately paints a picture of a bucket of bunch of tools, right? And we developers love tools. We want new tools every day. We get emotionally attached to our tools. My tools are always better than your tools, right? Don't take away my tools. I don't like your tools. Those kind of discussions are useless. Now, there's another viewpoint on the discussion that happens on the tool side. This tool sucks. See this new tool, this does X better than Y, and all those things. But all those people who are emotionally attached to their tools and get into the discussion of tools in everyday's life, let me start with the bad news. Your customers don't care about your DevOps tools. So that's the bottom line. So think about that for a moment. We actually don't, as a customers, care about your DevOps tools. But the tools discussion is never ending. I think most enterprises, especially the enterprises that are regulated, go through a similar journey on tools front. And let me explain what I'm trying to say. A typical DevOps or tools-based DevOps journey looks like this. And I'm going to kind of say that typically these kind of journey do not reach the final goal. So the first thing is every team starts with their own tools of choice, starting to automate away. This phase is very interesting and truly transformative. A lot of fresh ideas come in during this time. And then every team declares their success on their automation journey on the CI part, the continuous integration part. And it's not the end-to-end continuous deployment or continuous delivery for just the CI part. This is the phase where middle management starts to get involved and start evangelizing. This is the time when teams and leads and the middle managements get the visibility and kudos, and very rightfully so. And then some teams get onto the next level, automatically deploy into non-production environment and declare success. This is a huge win. At this point, the successful teams do not have to depend on anyone to deploy their code to non-production. However, at this stage, some new challenges show up. Lack of test automation. In many organizations, QA is still a separate function or silo or a different team. However, some teams actually automate enough test cases to be able to feel confident about an automated production deployment. But then comes the real challenge. The teams face change management team, cybersecurity team, risk team, and the audit team. The security scan, security testing, access control, who is doing what, segregation of duties, all these things now pop up and create a friction, huge friction, to the point that possibly have two outcomes. Development team leave the journey in the midway. Effort starts to centralize tools and pipelines. There's a new realization in the organization that, hey, this cannot be done this way. We need to bring in the other people in the process flow in our journey. And the biggest thing is that at this point, there's no end-to-end ownership also. Now, let me briefly bring up a real life story here. I was talking to someone in a leadership role in a company a few months ago. He told me that development teams in your organization, in his organization, do continuous deployment from code merge all the way to production. And that's what I thought that he meant. But I was very surprised when I asked more questions around it. I came to know that the teams do continuous deployments up to the non-production environment. Production deployment is completely a different process owned by an ops team. I was very surprised to know that we still have a lot of misconception about the whole process itself. So in general, I see more enterprises, they get more success around a tools centralization path, or what I call shared internal platforms path. There are better success stories around this. There are a few reasons why centralizing the tools and creating self-service internal platforms makes sense. Number one is cost efficiency. Definitely save on license and all the other operating costs. Process efficiency, reuse of resources, scripts, patterns, code, and whatever. It actually encourages collaboration between teams to build automation. And overall productivity increase is also there. Security audit compliance baked into the tools platform when done correctly. I'm not limiting this discussion just in the domain of CI/CD toolset, but also I'm trying to include security, monitoring, observability, container orchestration, everything in here. Here are some examples of such internal platforms that we can make use of. Continuous integration platform, that actually is the CI/CD platform that I've been talking about. Deployment and release engineering platform, security testing platform, test automation platform, monitoring platform, cluster management platform. These are all internal platforms that the whole enterprise or whole organization can use and does not need to be owned by each development team. Now, there are some challenges with the tools itself that we need to keep in our mind. Number one is lack of enterprise features within the tools. Most of the tools do not come with enterprise features such as single sign-on, role-based access control, and they don't have enterprise-grade scalability and availability that is needed. However, I haven't seen that things are changing and more tools vendors are realizing these and coming up with better features. But overall, I think it's still a big issue. The next is too many tools. Sometimes I just wish there are a lesser number of tools. I mean, you should see the DevOps tools periodic table published by ZBA Labs, right? Putting all these tools together in a simple consumable platform is no easy task. Most successful enterprises create one-stop shop for onboarding onto tools, presents a simpler way to configure things, abstract the underlying tools by themselves. Please do not ask all the developers to learn all the tools. It's not going to happen. Forcing all the developers to know each and every tool is definitely a recipe for disaster. The next one is short lifetime and ever-changing tools. There are new tools every day. And as soon as a new tool comes up, a group of engineers will lean towards the new thing. It's actually a good culture. However, organizations need to figure out how to best do that. Switching tools too frequently is a distraction by itself and can be actually very disruptive too. At the same time, not staying current can be a huge problem down the line. This ever-changing technology landscape will continue to be a challenge for large enterprises. The next is the developer experience or optimal developer experience. I think this is the single biggest thing we should all be paying attention to continuously. While centralizing tools, operations, and platform creations, the tendency almost always is to optimize it for the group that is going to operate the tools and the platforms. I think instead, the focus should be on the developer's experience. Just like any other customers, developers will not use a bad product. They will not subject themselves to a suboptimal experience. They will either work around it or create their own shadow IT. In many cases, they will even give up and give in. End result will be a low-performing organization. So a few slides ago, I talked about security, audit, compliance, etc., that become a friction in the journey. So let's talk about that. So here comes my next observation. One of my favorite topics, by the way, governance. Now you can throw in all these other terms into it: compliance, security, risk. And I think this is the most ignored side of DevOps, and it creates the most amount of friction. It's all about managing your risk, though. And to manage risks, you have controls. An audit is there to check if you're doing the things that you said you're going to do. Now, there are three minimum set of controls that are essential to this governance process. Number one is 2 sets of eyes. Plain and simple, every change needs to have another set of eyes. Least privilege, you should not have access to the things that you don't need to. And then only approved changes are allowed. Now, all the classic SDLC controls are based on this separation between dev and ops. Segregation of duties, which is basically an implementation of 2 sets of eyes, or confirms that there have been 2 sets of eyes. And segregation of duties means if you are a developer, you cannot build. If you're a developer, you cannot test. And of course, you cannot deploy. Least privileges lock down everything, right? Role-based access control to make sure only certain people have access, right? Or have right access to the servers or the things that they need to get to. And then the only changed only approved changes are ensured by a change approval board. Now, this is the best that we could do at that time, before DevOps. There was no automation. Were they effective? Did they actually work? Well, we can all talk about all those things all day, but no, the one thing is certain, that these were based on separation of dev and ops and QA and all the other verticals. In today's world, how do we design these controls? Where the basic assumption of separation is lost, meaning that DevOps essentially means get DevOps and dev and ops together. And by the way, get QA, security engineer, and everybody together, right? So how does these control work in the new world? And then before I go in there, let me just talk about some incorrect perception. Two sets of eyes. I talked about the legacy paradigm. Dev and ops is separate. Dev cannot deploy to production, and Dev cannot test, etc. And segregation of duties to ensure that there are two sets of eyes. I see the other extreme now. Just because we created this beautiful word called DevOps, and we have a DevOps team who wants end-to-end, there is no separation. And so we do not need two sets of eyes. That is absolutely not true. Just because there is no separation and it is DevOps, the perception is that everyone can have access to everything and they can do whatever they want. Absolutely not. Just because there is no separation and it is DevOps, the team owns everything. No one needs to approve anything. We can check the code and pipeline can deploy to production without talking to anyone or getting approval for anything or making any kind of validation. That is absolutely not true. These are wrong perceptions. We do need to have the same three sets of controls. Yes, the implementation may be different and should be better, but they are absolutely needed. Let's go through these one by one. The modern SDLC control based on objectivity. Two sets of eyes. We still need to make sure that there are two sets of eyes. One who made the change, the other who reviewed. The change includes any kind of change that is affecting production, including the changes in the CI/CD pipeline, including the changes in your CFT or Terraform template or in Docker file, anything. This means you need to have everything as code, your application, your infrastructure, your test, your configuration, everything. And in a source control or version management system. This also means every commit is peer reviewed. In GitHub and similar source control management tools, you have to turn on something called branch protection. However, as a repository owner, who is typically another developer from the same team, can turn off branch protection, right? So how do we detect that and how do you make sure that did not happen? Also, how do you know or how do you show it to the audit? Which branch is the release branch? What is your control to make sure you can produce a full traceability of your change to your source code? It's not easy. There are multiple ways to do this, by the way. You just need to find out what fits your culture and your SCM tool. The next one is the least privilege. Everyone agrees that we have to reduce the number of people having access to production. But I noticed that with DevOps, more and more people end up having right access to production. It should be just the opposite. In fact, I believe that a highly mature DevOps team should not need access to production, period. Read access is probably still okay, but write access, no. Infra and core changes should be happening only via the pipeline. Logs should be streamed out. And we should have enough observability built into the system to understand and handle failures. The fact that we still need production write access means only one thing. That is, the DevOps process is not matured enough in your organization or in your team. If you must have access to production, it has to be via a break glass mechanism, kind of checking out production access for a specific time. And while you are using that access, everything is recorded for future analytics purposes. So in essence, no one should have persisted write access to production. And every time there's a need to access production, there should be a break glass approach. Now, the last one, this is the only approved changes are allowed to go to production. Well, first of all, why do we need someone to approve something, right? Let me ask the question from the other side. Should we send out every code change to production as is? Of course, the answer is no. We need to package it at the very least. What else? How about testing? How about security scan? Yes. How about code review? Yes. How about user documentation update or user acceptance test? Notifying the users and stakeholders, right? We need to make sure that the proper monitoring is in place. Or a change approval board, right? The change approval board is the old way of verifying checks and balances. Automation is the new way. But one thing is for sure, just because we can write a deployment pipeline in a tool and call ourselves a DevOps enable team does not mean that we can actually send code to production without verification. Now, going back to the question of what all should be checked and verified before we send code out to production, it depends. It depends on how the delivery pipeline is set up. It depends on what goes through the pipeline. It depends on organizational risk management and risk appetite. So I've been fortunate enough to work on this subject for quite some time now in Jenkins DevOps Enterprise Forum. We as a team meet up in Portland, Oregon for 3 straight days sometime in April, virtual now, of course. And then we discuss and brainstorm on various DevOps challenges, and we do some white paper or research paper, and we publish them under IT Revolution Press. So one such paper was published in 2019, and I was a core contributor of this paper. It's called DevOps Automated Governance Reference Architecture. At a very high level, there are 2 parts to it, right? What to control and how to control. By the way, I have pasted the link on here if you want to take a note and go to this website and download this paper and read it. That would be fantastic. If you provide feedback, that would be even more better. So back to the topic. There are 2 fundamental questions: what to control and how to control. First is what to control. The reference architecture tries to address that by first using a very simple and generic delivery pipeline that is composed of various stages. So if you see these square boxes like source code repo build, these are all stages in the delivery pipeline. It's kind of, you start with source code repository, then build. While building, dependencies are pulled in from the dependency management system, and then you package it and publish it to the artifact repository. And then you go through the non-production deployment and testing, and finally end up in the production. You can add or modify the stages as needed, but that's kind of the basic generic structure. Now, remember, our goal is to find the controls that we need to mitigate the risks in the pipeline. And I'm just talking about the risks in the release process, not overall IT risks. This is just about software delivery lifecycle risk management process. Now, to do that, we will first need to isolate each stage. I use the technique that all physics students learned in high school. It's called free body diagram, where in a mechanical system, you isolate a single body from its surrounding and analyze or visualize the forces, the moments, and reactions on that single body. It's kind of based on that. So in our case, let's take a generic stage. Every stage has a set of input and a set of output. A set of actions are performed by a set of actors at every stage. At this point, we should be able to write down the risks in that system, in that isolated system. And our job is to mitigate those risks by implementing controls, certain controls. Now, given this isolated system, we can only control the input, the output, the actors, and their actions. There's nothing else needed in analyzing what needs to be controlled in this stage. So this paper actually walks through each and every stage in that generic pipeline and lists some sample risks and controls, sample actors and actions. Such an example is this. For example, let's take the source control stage where you actually code and put stuff, your changes in a source control tool like GitHub. In here, the input is request for change, like a Jira ticket or feature request or whatever that may be. The output is a new version of the code, a new head SHA, right? The actors are, of course, code author and code reviewer. The actions are code authors commit the code, creates a pull request, and then the code reviewer reviews the change and merges the code. The risks here we can list as, hey, you know what? The risk is that some unapproved changes are going through the system. Some untested changes are happening. Some unapproved third-party library dependencies are getting injected information, secret leakages are happening through the code, like some account login password or account number or whatnot. Low quality is code sent to production. These are all you can add more risk, you can take away, it's up to you. But then it allows us to actually create these controls on the right side, such as for unapproved changes, we need to have peer review. And then we can talk about how to implement peer review based on the things that you can control here, such as the actors, code author, and code reviewer. How do I ensure that peer review is happening for every change that is happening in the code? Unit test coverage, we can look at the unit test coverage. We can actually ensure clean dependency, all that. So again, this is just high level. This is a reference architecture. You can take it and extend it. Now, this is about what to control, right? Now, the how to control comes the next stage. And I'm just only going to cover the high level concept here. The details are in that paper. Please read the paper. So the idea about creating the controls, the idea here is to publish events from all these stages to an event stream to produce immutable attestation that we can store in an attestation store or evidence store, and then evaluate later on even present them for audit. With these, there's no more human-centric subjective attestation. It's all about objective, immutable, and hence reliable attestation, and it is auditable. Let me stop right here on this topic again, and I want to show you the paper and the link. Please take a look and provide feedback. The next is my last observation about measurement. It is quite important in the DevOps journey that we measure things to know how we are doing, if we are going in the right direction, where are we compared to others, what should we be measuring, and then actually at the end, we need to show positive results or positive changes to our stakeholders, not only to the stakeholders, but the developers also. They should be encouraged to see that, yes, things are moving. But the question is, what should we measure, right? And how should we measure? And the third question is, when should we measure? What is good? What is bad? Where should we focus on? And how do you tell if the measurement is good or bad? How do you rely upon measurement itself? I think this is the most confusing aspect of DevOps. Now, there are wide ranges of metrics and measurements available, but I think there's no common understanding about what they are. I'll list all these measurement techniques that exist in the industry, and there are many more. I really, really like each of these. And there, as I said, there are many more. But I think this is quite a lot. This is a whole lot of things to be measured. It is very confusing, and at the end, nobody knows what's going on in the system. And I also think that there's a tendency that we abuse these measurements in many ways. We use them to compare and contrast teams. We use them at the wrong time. We use them to focus on the wrong things. Some of us even use them in individual performance evaluation, which is ridiculous. We also sometimes use them just because someone asked us to, or use them to take a shortcut. For example, the DORA matrix. The book Accelerate is one of my favorite DevOps book. I still have it with me. Next to me, I keep reading this, right? Now, this book has about 250 pages of material, minus the cover and the acknowledgements and the table of contents. But people only pick out few pages of that book and call it DORA matrix. The book has a lot of other information, about 16 chapters, and it talks about a lot of good things that you should be doing. Instead of doing those, people, I think, take a shortcut by saying that I'm just going to measure those 4 things, and that's it. There's no answer as to what those measurements will do to me. So before we go on to this measurement business, I want to go back to some basics about measurements. So basic question is, when should you measure, what to measure, and how to measure? Or in other words, how do you avoid blindly using measurements, right? So I think every measurement has a time and precondition. In this context, there is no point measuring lead time when there is no CI pipeline or source control tool. At the same time, there's no point measuring commit frequency for a very high performing team. They are already there. Why are we measuring these? We need to measure something else at that time. So the time and precondition is very important in the decision-making process as to what we should measure. Every measurement should have at least one standard technique. In our context, how do you measure productivity? How do you count number of deployments? What is a deployment? Is infrastructure change a deployment? Is application change a deployment? Is feature toggle a deployment? Is OS patch a deployment? And even deploying to one server, does that count as one? Deployment to 500 server, the same change, does it count to 500? There's no standard. It needs to be there, right? Otherwise, it doesn't make sense. I think in my mind, a measurement must have a goal or ideal value range that we can define at least at an organization level. What should be the ideal value of, say, lead time or deployment frequency or commit frequency or velocity, whatever that is? There should be an ideal value range. It should not be, okay, we'll just keep doing, we'll tell you when it's good or bad. Lastly, there should be a context of subject of measurement. Who are we measuring? A person, a team, a product, a component, or the whole organization? Unless we settle on these first, all our measurements will be ineffective. By measuring deployment frequency, should we add up all the 1,000 applications that are going through deployments every day and present that as an organizational thing? Or should we just take one application? Or should we even take one developer and measure their commit frequency, right? We don't know. So different measurements have different context or subject of measurement. As I said, unless we settle on this first, all our measurements will be ineffective. I think each organization needs to select the things that they want to measure and apply these fundamentals before starting to measure and not blindly pick a metric system. Good news is that there are enough data points available in modern days development tools, and we have enough tools available to analyze the data. At the same time, I am, along with some other my network connections, are trying to figure out, can we come up with a better set of measurements? May not be better, maybe a different one, but at least, kind of comply to the standards that you are talking about here. We can answer the time and precondition, the standard technique questions, or the goals or ideas, value chain, value range, or the context of the subject. So I'd like to get some feedback if possible. You can ping me via LinkedIn or Twitter, or just send me an email, I guess. So with that, let me just go through this step by step. And again, as I said, this is work in progress. I need some feedback. The first is production access date. And I'm going to talk about this in a little more detail. I think the production access date is a perfect indicator for a super mature DevOps team. The idea is that no one should need to access production, even for read. So 0 is the ideal. Every time someone accesses production, a date is added. I think this is a powerful measurement because to get to 0, you need to have all the DevOps best practices in that particular team or the product. Everything as code, change only via pipeline, and even your observability should be solid and all that. And along with that, you need good engineering culture. Otherwise, you won't even get there. To make sure on the other side that we are not affecting customers or end users, we want to measure total downtime date. So at the same time, we are measuring production access date. We need to make sure that by taking your access away, we are not impacting the customers. So we want to measure that. How do you measure that? we'll talk about in a future slide, but ideally zero. Finally, to make sure that by trying to meet the above two ideals, which is no production access and no downtime, we are not just sitting idle. We need to make sure that you are still working on new feature requests or new technical data requests, or maybe even fixing your CVEs or vulnerabilities or doing your OS patch. We need to make sure that system is not sitting idle. It's actually changes are happening, upgrade is happening, enhancements are happening, bug fixes are happening, all those things. So in using this combination of these three measurements, I think we can paint a good picture of the context here. It's a product-based approach. Now, let's get to a little more detail. Production access date calculation. How do you calculate? These are some of the high-level thought process. Again, as I said, would love to get your feedback on this. So the production access date calculation, the idea is to measure the engineering and cultural maturity. So let's say we create a calculation system. Each persistent production account costs you negative 25 points. Each break glass write access costs you negative 5 points. And each break glass read access costs -1 point. Over a period of time, you add all this up and see how below you are compared to zero. The more negative you are in, the worse you are. The ideal is to get to zero. So you have a target to get to zero. It's not actually saying how do you get to zero. It's basically saying I'm going to tell you when you are not zero, right? So teams need to figure out how to get to zero, how to remove production access and still do the day-to-day business. The next is total downtime beyond budget calculation. I think this indicates system stability, low change failure, and all those things. Now, budget is based on the product's resiliency tier. Do you claim to be 99.99% available? In that case, your budget is 4.38 minutes per month. Do you claim to be 99% available? In that case, it is 7.31 hours per month. Now, sum of all the downtimes, you sum it up, whether it's due to deployment or incidents or OS patch or whatever, sum it up. And then if you are within budget, your score is zero, right? If you sum up all your downtimes throughout the month, if you are a 99% resilient application, does it add up to 7.31 hours? If it is less than that, your score is zero, which is ideal. If it is more than above, if you are above budget, then normal is a score to percentage of availability degradation. And you can play around with this number, come up with your own set of calculation, that's fine. But the idea is that here, the main point is that we have an identification or indication whether the system is stable, whether there are low change failure, whether things are actually serving the customer the way it needs to be. The third one is median duration of tickets remaining open, calculation of that. I think this measures the velocity or the flow rate. Now, what are the tickets? It's Jira tickets that have user requests or stories or feature requests, whatever you call that. And those are mostly the business requirements, right? Business is asking for new stuff. The next set of tickets are what I call technical dates. They usually show up in GitHub issues because they are created by the developers, maybe some business users too, and depending upon your organization structure and the culture and the working process. The GitHub issues talk about the technical dates that you need to fix, such as refactoring a code or upgrading your libraries and so on and so forth. Then the next one is the bug tracker. These are the bugs that are reported by various users or the support people or whoever, or even including the developers. The CVEs, the vulnerabilities, end-of-life notification system, such as, hey, this particular library is out of date, you need to upgrade that and all that. Now, take all these tickets and calculate the duration of how long these tickets are open and get the median. The goal is to minimize it. We still have not found out an ideal value because it depends. If you have any idea, please let us know. But the goal here, again, as I said, is to measure the velocity or the flow rate. Now, the production access date, and why do I think it is the most powerful measurement? So let me back that up by some logic. So here we are saying that nobody is going to access production. However, they need to make changes to the production. They may need to send out new features. They need to upgrade OS, or they need to fix vulnerability. What does that mean? That means everything is as code, whether it's application or infrastructure, it doesn't matter. Everything is as code. And at the same time, all logs are streamed out, because if there are incidents or if you want to observe something of the system, you're not actually going into the system or the server. You are actually sending out all the logs out and observing those signals coming out of the system. And then you have fully automated pipeline to update application as well as infrastructure. And in many times, you would have automated or on-demand release, meaning that you're not actually logging into the server and upgrading anything, right? It's totally out of the server, and you have full automated process. And at the same time, you have best-in-class observability. It's not just about streaming the log out. I mean, that's the basic, right? Now, you need to have enough monitoring, enough alerting, enough logistics to make sure that you can actually observe and predict when the system is going down. You need to have that. And then to do all this, you need to have a good engineering culture and collaboration along various teams in your organization. Because this is the guts of DevOps, right? Everything as code, everything is streamed out, best-in-class observability. So this, at this one single measurement, I passionately think the one single good measurement is this: how many times people need production access. Now, granted that sometimes beyond all these, there are situations, high severity incident, everything goes down, all hands on table kind of situation, then you do need production access. Probably it's better, right? You do not affect the customer or impact the customer experience. That's when you need the break glass approach, but you still count them just to make sure that you are on track. Now, with that, I'll ask you to, again, go through this and send me feedback on my Twitter account or on my LinkedIn page. I definitely want your opinion and your concern or your questions I want to answer, and your feedback on this particular subject. With that, I'd like to thank you all for listening to me, and thanks to the organizer for giving me an opportunity to speak. Let me know if you have any feedback. You can connect or contact me through LinkedIn or Twitter. Thank you very much.